friends, here we are, Joshika
and Anisha.
We, the students of grade 8, are here to do this year's project day. Let's start the day with the prayer. ततो युद्धपरिश्रान्तं समरे चिन्तया स्थितं रावणं चाक्रतो दृष्ट्वा युद्धाय समुपस्थितं दैवदेश्च समागम्य दृष्टुमभ्यागतो रणम् उपागम्य ब्रवीत् रामम् अगस्त्यो भगवान् ऋषिः राम राम महाबाहो शृणु गुह्यं सनातनम् येन सर्वा नरीन् वत्स समरे विजयिष्यसि आदित्य हृदयं पुण्यं सर्वशत्रुविनाशनं जयावहं जपेन्नित्यम् अक्षयं परमं शिवं सर्वमङ्गलमाङ्गल्यं सर्वपापप्रणाशनं चिन्ताशोकप्रशमनम् आयुर्वर्धनमुत्तमम् ॐ शान्ति शान्ति शान्तिः.
This year's project day is on the topic of nuclear reaction in space, especially in the sun and the stars.
Nuclear fusion is a nuclear reaction in which atomic nuclei of low atomic number fuses to form a heavier nucleus with the release of energy.
The sun, like other stars, is a ball of gas.
In terms of atoms, it consists of hydrogen and helium.
Solar radiation is a radiated energy emitted by the sun from a nuclear fusion reaction that creates electromagnetic energy.
Cosmic rays are high energy protons and atomic nuclei that move through space at nearly the speed of light.
It has an effect on the environment, human being on the earth and the space, and many more, which we will see in the upcoming videos.
The energy from the sun, both heat and the light energy, originates from the nuclear fusion process occurring inside the sun's core.
We also have other interesting topics like stellar synthesis, which creates chemical element by nuclear fusion reaction within star.
Another interesting topic is supernova, which is a powerful and luminous stellar explosion.
Speaking of luminous stuff, I get to remember the stars and stardust.
A star is an astronomical object consisting of a luminous spheroid of plasma and held together by its own gravity.
Stardust may seem comical and frictional, but is it?
No, definitely not. Stardust is a scientific term referring to refractory dust grains that condense from cooling ejected gases from individual pre-solar stars.
That incorporated into the clouds from which the solar system condensed.
Our students of Class 8 have worked assiduously to let you dive into a bundle of knowledge about nuclear reactions. Easy to understand PPTs,
Detailed explanation,
illustrative videos,
tuneful songs,
and
and fun facts will make your time memorable. Have a fun time!
have a fun time!
The weather is so hot.
I love this balmy weather.
I wish I could eat an ice cream. The ice cream will surely melt in this burning weather. I wonder what is inside the sun that is causing this hot weather.
I think it's the core of the sun that causes all of this.
What is core?
The core of the sun is considered to extend from the center to about 0.2 to 0.25 of the solar radius. It is the hottest part of the sun and of the solar system. It has a density of 150 gram per centimeter cube at the center and a temperature of 15 million kelvins.
So I guess the next layer is radiative zone.
Why is it called the radiative zone?
This zone is called the radiative zone because it is a zone that carries the energy produced in the core via radiative diffusion. The radiation zone is a layer of the star's interior where the energy is primarily transported towards the exterior by means of radiative diffusion and thermal conduction. Energy travels through the radiation zone in the form of electromagnetic radiation as photons. Here the temperature is about 100,000 Kelvin.
So, does the energy now directly pass through space and reach us?
No, there is another zone called convection zone. As the name suggests, this zone carries the energy released from radiative zone convection. A convection zone is a region of a star is a layer which is unstable due to convection. Energy is primarily or partially transported by convection in such a region. In a radiation zone, energy is transported by radiation and convection.
So, what's the next layer?
It is photosphere. It is known as the surface of the sun. But isn't unlike a plasma? How can it have a surface?
Yeah, isn't sun like a plasma?
Yes, Sun is a plasma, so technically it does not have a surface, but still we call the photosphere as the surface of the Sun because this is where light escapes. Did you know the photosphere is the lowest layer of the solar atmosphere? It is essential that we know the solar surface that we get to see when we look at the Sun in white light. And also, the photosphere is the deepest layer that we directly observe. It reaches us from the surface visible from the solar disk in about 250 miles or 400 kilometers, sometimes even more than that. Last but not least, the photosphere is the deepest region of a luminous object, which is usually a star. It is transparent to photon and certain wavelengths. So that is it. That explains the layers of the sun.
No, just like the Earth, the Sun also has an atmosphere. The first layer of the atmosphere of the Sun is chromosphere. This layer is about 2000 to 3000 kilometer deep. Here the temperatures are as high as 10,000 Kelvin. So the next layer of the atmosphere of the Sun is the transition region. This region has a temperature of 2 lakh Kelvin.
Shouldn't the temperature be less in the outermost layer?
Astronomers have been trying to solve this mystery for a long time. The corona is the outer layer of the sun's atmosphere, far from its surface. Yet, the corona is hundred of times hotter than the sun's surface. A NASA mission called IRIS may have provided one possible answer. The mission discovered packets of very hot material called heat bombs that travel from the sun's surface into the corona. In the corona, the heat bombs explode and release their energy as heat. But astronomers think that this is only one of many ways in which the corona is heated.
Is that virus even in the Sun?
Good morning to one and all present. Hello, we are from Group 2 and we will briefly explain the world of stars. A massive ball of gas, which is luminous, is called as a star. It contains the first two elements of the periodic table, which are hydrogen and helium in its core. Many of the stars are visible to the naked eye at night, but due to the immense distance from Earth, they appear as fixed points. This fun facts. This is Anaxagoras, and he is a Greek philosopher who became the first person in history to suggest that the stars were other suns such as our own. Thank you. Now moving on to Sai Ganesh. He will tell about the composition of stars.
Hi, I'm Saidinesh. I'm going to tell about the composition of star. So, what is composition of star? The thermonuclear reaction is nothing but the changing of hydrogen into helium in its core. The thermonuclear fusion releases energy that travels the star inner and that radiate into outer space. space. The following are emission line spectrum of the four elements hydrogen, helium, lithium and oxygen from top to bottom. The, the first image here is described as an onion ring by mentioning the composition of star. The second image shows the sun looking like a piece of cake that is cut. This also shows the composition of star in more detailed way. The third image shows the outer cover that is peeled and it shows the inner composition of star. Next we will be explain about stellar evolution. Thank you.
Good morning everyone, I am Dhruv of 8B and today I will be speaking about the topic stellar evolution. So what is stellar evolution? Stellar evolution is the process by which a star changes over the course of the time. A star is born, lives and dies much like everything else in nature. Using observations of stars in all phases of their lives, astronomers have constructed a life cycle that all stars appear to go through. The fate and the life of the star depends primarily on its mass. Stellar evolution for low and medium mass stars. In this process, the first stage is the nebula. The gas. So in the nebula, the gas begins to ionize, separating the electrons from the nuclei as the sphere continues to heat up as it continues to collapse due to the gravitational force that plays in. Then comes the main sequence star. In this, the central temperature of the contracting protostar increases to the point where the nuclear reaction begins. Then comes a giant. Here is the main part and where the hydrogen converts into helium. Then comes the planetary nebula. So in the planetary nebula, the star becomes a white dwarf and the expanding gas cloud becomes invisible to us. Thank you.
Toshika Shri, and I'm going to talk about the stellar evolution of high mass stars. High mass stars are nothing but stars with heavy mass. Like low mass stars, high mass stars are also born out of a nebula. The star which is born out of a nebula is known as the main sequence star. Main sequence star goes to its next stage called a giant when it triples of the mass of the sun. So what is the mass of the sun? Mass of the sun is 1.989 into 10 to the power of 30 kilograms. So the star reaches the depth of its life when the helium fuel runs out of it and the star's core changes into iron. And the fusion which gives out energy will be taken inside to break the core of the star. Meanwhile, the gravitational pull of the star increases and it starts eating the substances present in it. And this leads to the final phase of the star called the supernova. And the supernova leads to the formation of black holes and neutron stars. Neutron stars are collapsed cores of high mass stars. Neutron stars are said to be of two types, pulsars and magnetars. Neutron stars are originally identified as pulsar. So what is pulsar? Pulsars are neutron stars are very small and has a triple times the mass of the sun. Anything which is very small and has high mass are said to be oscillating. Hence, oscillating neutron stars are known as pulsars. Magnetars are neutron stars with insanely high magnetic field. Now let's hear amazing facts on stars.
Facts on stars. The fastest known spinning is the neutron star, rotates about 700 times each second. The wrong kind of neutron star could wreak havoc on Earth. Most stars travel the galaxy with companions or in clusters, but not all stars do that. Our Sun, for example, moves through the galaxy without a stellar companion. Stars are black bodies. A black body is an object that absorbs 100% of all electromagnetic radiation. Red dwarfs are the longest living stars in the universe.
Is there any relation between the color and the temperature of a star? In very simple terms, a hotter object emits more high frequency radiation than a less hot one. For the sake of this explanation, a hot object will have a temperature of around 15,000 Kelvin, a warm object will be at approximately 6,500 Kelvin, and a cool object will be around 1,500 Kelvin. In other words, as the star becomes hotter, the light it emits is pushed towards the blue end of the spectrum. Star color blue, approximate temperature 25,000 Kelvin. Example Spica. Star color white, approximate temperature 10,000 Kelvin. Example Vega. Star color yellow, approximate temperature 6,000 Kelvin. Example Sun. Star color orange, approximate temperature 4,000 Kelvin. Example Aldebaran. Star color red, approximate temperature 3000 Kelvin. Example Betelgeuse.
I knew it. Everyone's super. But if you're super, do you want to find out something more super? It's more intriguing and mind blowing. It's something massively super. It's called supernova. Well, now that I got in your attention, let me and my friends give you a virtual tour about it. Let's jump straight into it, shall we?
What is a supernova? A supernova is a powerful and a luminous stellar explosion. On average, a supernova will occur about once every 50 years in a galaxy the size of the Milky Way, or when a white dwarf is triggered into runaway nuclear fusion. These transit astronomical events occur during the last evolutionary stages of a massive star. Types of supernova. The first type of supernova happens in binary star systems. Binary stars are two stars that orbit the same point. One of the stars, a carbon oxygen white dwarf, steals matter from its companion star. Eventually, the white dwarf accumulates too much matter. Having too much matter causes the star to explode, resulting in a supernova.
The second type of supernova occurs at the end of the single star's lifetime. As the stars run out of nuclear fuel, some of its mass flows into its core. Eventually, the core is so heavy that it cannot withstand its own gravitational force. The core collapses, which results in a giant explosion of supernova.
Where do supernovae take place? Supernovas are often seen in other galaxies, but supernovae are difficult to see in our own Milky Way galaxy because dust blocks our view. NASA's Chandra telescope discovered the remains of a more recent supernova. It exploded in the Milky Way more than 100 years ago. A supernova happens where there is a change in the core or center of the star. On average, a supernova explosion occurs within 10 parsec (33 light years) of the Earth every 240 million years. Gamma rays are responsible for most of the adverse effects that a supernova can have on a living planet. The collapse happens so quickly that it creates enormous shock waves that cause the outer part of the star to explode. That resulting explosion is a supernova. The resulting star core is called a white dwarf star.
Various civilizations recorded supernovae long before telescopes were even invented. The oldest supernova recorded is RCW 86, as Chinese astronomers saw in AD 185. Their records show that this gas star stayed in the sky for a possible 8 months, according to NASA. In the 17th early century, the when the telescopes were invented, they show that the only 7 recorded supernovae are there, according to the Encyclopedia Britannica.
When was the last supernova? The most recent supernova to be seen in the Milky Way galaxy was SN 1604, which was observed on October 9604. Several people, including Johannes van Eyck, noted the sudden appearance of the star. But it was Johannes Kepler who became noted for his systematic study of the object itself.
Supernova explosion on the left is supernova in 1987 after the star has exploded. On the right is the star before it explodes. A supernova is large explosions that take place at the end of the star life cycle. Will Sun never supernova? As HEE 2,26,868 note his answer, the Sun is not going to go supernova. This is something only large stars experience at the end of this main sequence life. Our Sun is rare star. It is not big enough to do that. It will interest expand to be a red giant when it burns out the hydrogen at very core of the sun.
Can a supernova destroy Earth? A supernova is a star explosion, destructive on a scale almost beyond human imagining. If our star exploded as a supernova, the resulting shockwave probably wouldn't destroy the whole Earth, but the side of the Earth facing the Sun would boil away. Clearly, the Sun's distance, 8 light minutes away, isn't safe.
An autobiography of a supernova is a dramatic end to a star's life. Supernovae, which is the plural form of supernova, becomes very bright and causes an enormous burst of radiation that can outshine an entire galaxy before disappearing. The outburst usually lasts about a month and explodes much of the star's remaining matter at an extremely high rate of speed, typically around one-tenth of the speed of light. This creates a shock wave that affects the interstellar medium in the vicinity of the supernova.
Scientists who worked on supernova, Fritz Zwicky, 1898 to 1974, along with Walter Ball, coined the term supernova, contributed in understanding neutron stars, supernovae, as standard candles, gravitational lensing and dark matter. You do not have to be a scientist or even have a telescope to hunt for supernova. For example, in 2008, a teenager discovered a supernova. Then in 2011, a 10-year-old girl from Canada discovered a supernova by looking at night sky images on her computer. The images taken by amateur astronomers just happened to include a supernova. With some practice and right equipment, you can find the next supernova.
I'm Renan from class 8B. Today I am going to explain about what is stardust in space. Cosmic dust is a cosmic dust, also called extraterrestrial dust or space dust. It's dust which exists in the outer space or has fallen on the Earth. A smaller fraction of dust in space is stardust, consisting of a larger refractory mineral that contains just a matter left by stars. Now, what is stardust made of? According to science, stardust is made of particles remaining from a supernova explosion. Though we could wrongfully believe stars will shine forever, like ourselves and every other being. The stars are born and they live and they die. A human is made of stardust. Stars that go supernova are responsible for creating many of the elements of the periodic table, including those that make up the human body. It's totally 100% true that nearly all the elements in the human body were made in a star, and many have come through several supernovas. Over to Saurav.
My name is Saurav. Stardust grains, also called prestellar grains by meteoritics, are contained within meteorites, from which they are extracted in terrestrial laboratories. Stardust was a component of the dust in the interstellar medium before its incorporation into meteorites. The meteorites have stored these stardust grains ever since the meteorites first assembled within the planetary accretion disk more than 4 billion years ago. So-called carbonaceous chondrites are especially fertile reservoirs of stardust. Each stardust grain existed before the Earth was formed. Stardust is a scientific term referring to refractory dust grains that condense from cooling ejected gases from individual pre-solar grains and incorporated into the cloud from which the solar system condensed. Over to Sarah.
I'm Sarah of class 8A. Many different types of stardust have been identified by laboratory measurements of the highly of chemical elements at unusual isotopic composition compressed each stardust grain. These refractory mineral grains may earlier have been coated with the volatile compounds but are those lost in the dissolving of meteorite matters in acids, leaving only insoluble refractory minerals. Finding the grain cores without dissolving most of the meteorite has been possible but difficult and labor intensive. Over to Samriddhi.
I am Samriddhi of Class 8A. Many new aspects of nuclear synthesis have been discovered from the isotopic ratios within the stardust grains. An important property of stardust is the hard refractory, high temperature nature of the grains. Prominent are silicon carbide, graphite, aluminium oxide, aluminium spinel, and other such solids that would condense at high temperature from a cooling gas, such as interstellar winds or the decompression of the inside of a supernova. They differ greatly from the solids formed at low temperature within the interstellar medium. Fun fact, how is a star born? Stars are born in places called nebulae. Formed by gas and dust, a nebula's main element is hydrogen. Over time, due to gravity, they begin to collapse, forming a nucleus. Through a process known as nuclear fusion, a course that can take millions of years to develop, the star nuclei increases its temperature, transforming hydrogen into helium, the fuel that makes every star shine. And like so, in the midst of a cosmic spark, stars are born. Over to Janani.
I am Janani from class 8B. Also important are their extreme isotopic compositions which are expected to exist nowhere in the interstellar medium. This also suggests that the stardust condensed from the gas of an individual star before the isotopics could be diluted by mixing with the interstellar medium. These allow the resource stars to be identified. For example, the heavy metals within the silicon carbide grains are almost pure S-process isotopics, fitting their condensation with the AGB star red giant. In as much as the ABG stars are the main resources of the S process, the nucleosynthesize and have atmosphere absorbed by the astronomers to be highly enriched in the dredged up S process elements. Over to Prakul.
Good morning everyone. My name is Prakul Pavanich from class 8A. Another dynamic example is given by the so-called supernova condensate, usually shortened by acronym to SUNOCO to distinguish them from other stardust condensed within the stellar atmosphere. Sonocon contain in their calcium excessively large abundance of calcium, demonstrating that they condense containing abundance radioactive Ti, which has 65 years of half-life. The outflowing Ti nuclei were still alive, radioactive when the Sonoko condensed near 1 year within the expanding supernova interior, but could have become an extinct super radio played. After the time required for mixing with the stellar gas, its discovery proved the possible identity sonocon in the way the sick sonocon are only about 1% as the numerous are sick stardust from AGB stars. Thank you. Over to Aditya K.
I'm Aditya K from class 8B. Stardust itself, sonocons and AGB grains that come from specific stars is but a modest fraction of the condensed cosmic dust, forming less than 0.1 of the mass total of interstellar solids. The high interest in stardust derives from new information that has brought to the sciences of stellar evolution and nucleosynthesis. Laboratories have studied solids that existed before the Earth was formed. This was once though thought impossible, especially in the 1970s when cosmochemists were confident that the solar system began as hot gas, virtually devoid of any remaining solids which would have been vaporized off by high temperature. The existence of stardust proved this history picture incorrect. Over to Charu.
I am Charu Hasini of 8A. Stardust is expansion of stars. After the explosion of the star bursts. This bursting of star is called supernova. Many different types of small stars are called isotopes. Stardust grains are also called as presolar grains by the meteorites. Stardust itself contains an AGB grains which come from specific stars. A dust particle interacts with the electromagnetic radiation in way that depends on its cross section, the wavelength of the electromagnetic radiation, and on the nature of the grain, its refractive index, size, etc. The radiation process for an individual grain is called emissivity, dependent on the grain's efficiency factor. Further specifications regarding the emissivity process include extinction, scattering, absorption, or polarization. Thank you.
Good morning everyone, this is Mukesh of class 8A. We are going to present a PPT on how does nuclear fusion begins. I am from group 5, share information on nuclear fusion. Over to Tejas.
Thank you, Mukesh. What is nuclear fusion? Nuclear fusion is a reaction in which two or more atomic nuclei are combined to form one or more different atomic nuclei and subatomic particles. Fusion is a process that powers active or main sequence stars and other high magnitude stars where large amounts of energy are released.
Now let's see how does nuclear fusion end. For this, first we need to know how does the sun become a red giant. The length of a star's lifespan depends on its size. Our sun is a yellow dwarf with a diameter of around 8,64,000 miles, that is 1.4 million kilometers. Yellow dwarf stars live for about 10 billion years, and at 4.5 billion years old, our middle-aged sun is about halfway through its lifetime. Once its hydrogen supply is depleted, the sun will start consuming its heavier elements. During this volatile and turbulent stage, vast quantities of stellar material will hurtle into space and the sun's body expands to 100 times its certain size, becoming a red giant. Then it will sink down to a tiny, extremely dense white dwarf star about Earth's size.
What happens to the sun in the red giant phase? In about 5 billion years, the sun will run out of hydrogen. That's when the sun will become a red giant. As the sun enters its red giant phase, the outer layers will slowly lose their gravitational attraction to the core. This will cause two important processes to occur. First, no longer constrained by gravity, many layers in the envelope will be lost into free space. Thus, over time, the sun will shrink, though it will really just go through a process of losing matter until only a gaseous core is left. The second, the lack of gravitational compression in the core will cause the process of nuclear fusion to stop. Since there will be no longer force capable of fusing atomic nuclei together, without nuclear fusion in the sun's core, the sun's essential becomes useless to us. We will no longer have source to the power our planet.
Now let us know some facts on nuclear fusion. Nuclear fusion is real and it works. Nuclear fusion is the same process that powers the sun. Nuclear fusion can provide an infinite supply of energy. That is, Fusion produces energy by fusing two hydrogen isotopes, deuterium and tritium. They are virtually inexhaustible. Deuterium comes from ocean water and tritium is produced from lithium as a byproduct of the reaction. Fusion emits no pollution or greenhouse gases. The byproduct of this fusion process are helium and a fast neutron. This fast neutron carries the heat to make steam. Hence, there is no long-lived radioactive waste is produced.
Nuclear fusion in stars. Stars are giant nuclear reactors. In the center of the stars, atoms are taken apart by tremendous atomic collision that alter the atomic structure and release an enormous amount of energy. This makes stars hot and bright. Stars are powered by nuclear fusion in their cores, mostly converting hydrogen into helium. The production of new elements via nuclear reaction is called nucleosynthesis. A star's mass determines what are the type of nucleosynthesis occurs in its core or during explosive changes in its life cycle. Each of us is made from atoms that were produced in stars and went through a supernova.
Advantages and disadvantages of nuclear fusion. Advantages of nuclear fusion. Nuclear fusion doesn't create harmful waste. There is an infinite amount of fuel for nuclear fusion. It is incredibly inexpensive to create. It is less risky. Global warming can still be negated without energy loss.
The disadvantages of nuclear fusion: the difficulty for achieving the fusion power, the radioactive waste, need more investigation and brain power is required in order to solve its problems. Its practical energy results are still unconservably unreachable.
Listen and enjoy the Group 6 song on nuclear fusion.
You know that sun can light up the sky.
But did you ever wonder why?
Deep inside its fiery core, the sun is always toiling, making energy galore. It's scorching cause they're boiling. The process is amazing. Could it be a delusion? Knowing how see this stuff is real, thermonuclear fusion. Thermonuclear fusion. It's not an illusion.
To get it just right, it could be the conclusion to our energy world. Thermonuclear fusion.
Hydrogen atom fuel the sun. They have atomic number 1. Scientists said no hydrogen duo gets together as something new. And can you guess what the steam do? They change to helium, it's true. They also mix the heat and light. That's why the sun is hot and bright.
Nuclear fusion. It's not an illusion if we get it just right. It could be the conclusion to our energy world. The confusion.
If we could do the same on Moon, it would all be full of joy and we still got a way to go before we can make the fusion flow. Can a big contraption shaped like a donut? Scientists try to make that fusion go, but they still have some things that they need to learn so they can make that sun power right.
Thermonuclear fusion. Thermonuclear fusion. It's not an illusion if we get it just right. It could be the conclusion to our energy woes. Conclusion to our energy woes. Conclusion to our energy woes. Thermonuclear fusion.
There are many inspiring and intriguingly clever and wise scientists and physicists involved in the discovery of nuclear fusion reactions in space. Here are a few of them: Anthony Henry Becquerel, Niels Henrik David Bohr, Albert Einstein, James Chadwick, and Marie Curie.
I'm Rachna from Class 8. I'm here to talk about Antoine Henry Becquerel. He lived between 1852 to 1908. Antoine Henry Becquerel was a French engineer, physicist, Nobel laureate, and the first person to discover evidence of radioactivity. For work in this field, he, along with Marie Skłodowska, Curie, and Pierre Curie, received the 1903 Nobel Prize in Physics.
Holly Compton. Arthur Holly Compton was an American physicist who won the Nobel Prize in Physics in 1927 for his 1923 discovery of the Compton effect, which demonstrated the particle nature of electromagnetic radiation. Throughout the 1930s, Compton conducted extensive research on cosmic radiation, which helped establish that at least some cosmic rays are charged particles. The Compton effect demonstrates that light cannot be explained purely as a wave phenomenon. Compton's work provided convincing proof that in scattering experiments,
Albert Einstein from 1879 to 1955. Albert Einstein was a German-born theoretical physicist, widely acknowledged to be one of the greatest physicists of all time. Einstein is known for developing the theory of relativity, but he also made important contribution to the development of theory quantum.
Hi, I'm Chennaai and I'm going to be talking about James Chadwick. James Chadwick was born in 1891 and died in 1974. Sir James Chadwick was a British physicist who was awarded the 1935 Nobel Prize in Physics for his discovery of the neutron in 1932. In 1941, he wrote the final draft of the Maud Report, which inspired the US government to begin serious atomic bomb research efforts. Chadwick graduated from the Victoria University of Manchester in 1911, where he studied under Ernest Rutherford, known as the father of nuclear physics. His discovery on neutron was a milestone in understanding the nucleus. He was awarded several awards for his discovery. Sir Chadwick was awarded the Hughes Medal by the Royal Society in 1932, the Nobel Prize in Physics in 1935, the Copley Medal in 1950, and the Franklin Medal in 1951.
Good morning to another presenter. I'm Rathanya of Class 8B and today I'm going to speak about Ernest Rutherford. Ernest Rutherford First Baron Rutherford Nelson, 30th August 1871 to 19 October 1937, was a New Zealand-born British physicist who came to be known as the father of nuclear physics. In early work, Rutherford discovered the concept of radioactive half-life, the radioactive element radon, and differentiated and named alpha and beta radiation.
Hello everybody, this is Aditi G from class 8A. So today in the project day, we are going to be telling about solar radiation, some of the basic principles. Solar radiation. Solar radiation, called solar resource or just sunlight, is a general term for the electromagnetic radiation emitted by the sun. So as you all know, sun produces the sunlight which falls on the earth. And now that sunlight is we take as energy to make solar radiation. As we can't depend on hydro dams for all electricity, we can take from the sun. It's also known as a general term for it is electromagnetic radiation emitted or thrown out or given by the sun. Now here are some of the basic principles. The amount of solar radiation that reaches the earth surface varies according. So as we all know, the sunlight varies according to the earth due to its tilt. Now, as we all know, the earth is tilted, the rays who don't fall are not totally equal. So here are some of the reasons why the rays also differ. Geographic location. As we all know, cold places like Antarctica have big mountains. Due to that, the solar radiation falling over there won't be good. Time of the day. It depends. If you're in a landlocked area, if it's morning, you can receive a lot of solar radiation. And if it's night, you won't much. Season. As we all know, summer season is known for the heat is summer. So during summer season, solar radiation will be produced the most. Meanwhile for the others, not much. Local weather. Even during summer, sometimes the weather may be cloudy, due to which solar radiation will be produced. So, due to all these reasons, we can classify or you can tell that solar radiation varies and differ from place to place. Thank you. Now, I pass on to Mithun.
I am Mithun Vijay from class 8A. My topic is diffuse and direct solar radiation. The rays that reach the surface without beginning diffuse is called direct beam. Solar radiation, as sunlight passes through the atmosphere, some of it is absorbed and reflected by air molecule, water vapor, cloud, dust, pollutants, volcanoes, forest fire. Thank you.
Causes of solar radiation. The solar radiation at Earth's surface varies widely due to, first cause, atmospheric effects including absorption and scattering. Scattering of solar radiation occurs when the radiation strikes very small particles in the Earth's atmosphere such as air molecules, ice crystals, which disperse the solar radiation all directions. Second cause, local variation in atmosphere such as water vapor, clouds and pollution. Third cause, latitude of the location. At higher latitude, the angle of solar radiation is smaller, causing energy to spread over large area of surface and cool at the temperature. Fourth cause, season of the year and time of the day. This is the main cause of solar radiation. These changes include variation in overall power received is incident on a surface. In addition, a key change in that variability of solar radiation at a particular location increases dramatically. Moving on to Manush.
How is solar energy used? We are able to consume solar energy using solar panels. The sun emits rays which is in the form of DC, direct current. But unfortunately, we are not able to derive electricity directly from DC. But luckily, we have inverters in solar panels which convert DC into AC, alternating current. So when the sun rises, the solar panels get to work. The DC is converted into the AC and then that alternating current is put out to the main panel and then it channels out to different applications like TVs, refrigerators, coolers, etc. Therefore, making our solar panels work.
I want to talk about advantages and disadvantages of solar energy. First, I'll be talking about advantages. Solar energy can be renewable. it reduces electricity bills, and because of the solar panels these days, technology has developed. Now I'm going to talk about disadvantages. First, solar panels can be very costly. We have to be weather dependent because if it's a cloudy, rainy or foggy day, we might not get solar energy that much. And a secret that you have all not known is that solar energy can be polluted. This is a disadvantage because some solar thermal systems have dangerous fluids which can be leaked sometimes. These fluids can be very dangerous to the environment. Thank you, and now moving on to Tejasvi.
Cosmic rays are high-energy protons and atomic nuclei that move through the space at nearly the speed of light. Cosmic rays were discovered by Victor Hess in 1912 in balloon experiments, for which he won the 1936 Nobel Prize in Physics. Upon impact with Earth's atmosphere, cosmic rays produce showers of secondary particles, some of which reach the surface, although the bulk is intercepted by the magnetosphere or heliosphere. Direct measurement of cosmic rays, especially at the lower energies, has been possible since the launch of the first satellites in 1950s. Particle detectors similar to those used in nuclear and high-energy physics are used on satellites and space probes for research into cosmic rays. Over to Srivarshini.
Cosmic rays originate from the Sun, from outside our solar system, in our own galaxy, and from distant galaxies. Cosmic radiation is produced when primary photons and particles from outside the solar system interact with components of the Earth's atmosphere. A second source of cosmic radiation is the release of charged particles from the Sun, which become significant during periods of solar flare, which is also called a sunstorm. Now, the next topic, which is facts, will be continued by Rishi.
Cosmic rays are formed by supernovas, the cataclysmic deaths of massive stars. Some rays hit the atmosphere near the speed of light, shattering into a shower of secondary particles. Cosmic rays are a hazard for satellites. This solar energy plant is in the Mojave Desert in California. Cosmic rays are very high energy radiation, mostly from outside the solar system. 1 hour of sunlight is equivalent to 1 year's worth of energy for the planet. Sunlight travels the 90 million miles to Earth in 10 minutes. Solar power plants can last more than 40 years. Gamma rays are the most harmful external hazard. Beta particles can partially penetrate your skin, causing beta burns. Solar panel costs have fallen 99% since 1977. Upcoming buildings will be made with solar panel technology. Thank you.
Hello there. Today we will learn about cosmic rays and its effect. Cosmic rays are high-energy protons and atomic nuclei that move through space at nearly the speed of light. Cosmic rays were discovered by Victor Hess in 1912 in balloon experiments, for which he won the 1936 Nobel Prize in Physics. Cosmic radiation is produced when primary photons and alpha particles from outside the solar system interact with components of the Earth's atmosphere. Cosmic radiation is one of the main health hazards. It is dangerous because it has sufficient energy to change or break DNA molecules, which can damage or kill a cell. Other effects of acute radiation exposure are much more severe, such as central nervous system damage or even death.
What is a nuclear reaction? A nuclear reaction is semantically considered to be the process in which two nuclei or a nucleus and an external subatomic particle collide to produce one or more nuclides.
Today, I'm going to be telling you about what a nuclear reaction in a sun is. So now, in the sun, when two nuclei atoms combine together, they form a larger one. Now this combination releases a high amount of energy. This energy is called nuclear energy, and this reaction is called a nuclear reaction. That too, in nuclear fusion, there is a very high amount of release in energy and a very low amount of nuclear waste. Thank you.
Nuclear fusion is the process that mainly converts hydrogen into helium. This produces a tremendous amount of energy in form of light and heat. The conversion of hydrogen to helium is the reaction that makes almost all life on Earth possible. Thank you so much.
Raw materials for fusion. Tritium. Tritium is an isotype of hydrogen which has two neutrons. It does not occur naturally. It can, however, be easily produced from the neutron bombardment of lithium, which is naturally abundant. Currently accessible reserves of lithium could supply all the world's energy demands for more than 1,000 years. Deuterium. Deuterium is an isotype of hydrogen which has one neutron. Its abundance is approximately 33 grams of deuterium in every cubic meter of water. As water is available in plenty, we have a whole lot of deuterium.
Advantages: environmental friendly as no greenhouse gases are produced. Virtually limitless fuel is available as the stocks are supposed to last for a really long time. Thank you.
Another advantage is there is no chain reactions, so no chance of major accidents. As the reaction can be stopped anytime but is cutting off the supply, which not to mention is already very low.
Now, let's look at some of the disadvantages of nuclear energy. So, the production of nuclear energy requires a lot of money. And now, second, the energy generated by nuclear energy is now less than how much it is needed to produce. And now, the most important effect is that when you produce a nuclear energy, the item on which it is to be produced is to be treated to manage the heat and the temperature it has to withstand. Thank you.
Stellar nucleosynthesis. Stellar nucleosynthesis is the creation of nucleosynthesis of chemical elements by nuclear fusion reactions with stars.
The process of nucleosynthesis. Nucleosynthesis is the creation of new atomic nuclei, the setters of atoms that are made up of protons and neutrons. Nucleosynthesis first occurred within a few minutes of the Big Bang. At that time, a quark-gluon plasma, a soup of particles known as quarks and gluons, condensed into protons and neutrons.
Where does stellar nucleosynthesis occur? Stellar nucleosynthesis occurs in stars during the stellar evolution. It is responsible for the galactic abundance of elements from carbon to iron.
Three types of nucleosynthesis. This synthesis is a naturally occurring element and their nuclei is present in the solar system. This synthesis is divided into three segments. They are primordial nucleosynthesis, He, energetic particle, Libe and B, and stellar nucleus. Primordial nucleosynthesis is a production of nuclei, those of the lightest nuclei of hydrogen. Energetic particles are high energy particles coming from the sun. Stellar nucleosynthesis is the creation of nucleosynthesis of chemical elements by the nuclear fusion reaction within stars. Thank you.
Nucleosynthesis and its data needs. Nucleosynthesis is an important nucleoastrophysics phenomenon that is responsible for presently observed chemical elements and isotoperences. It started in the early universe and presently proceeds in the stars. The Big Bang nucleosynthesis is responsible for the highly relative abundance of the lightest primordial elements in the universe. Thank you.
Hello everyone. I'm going to show you all a game which we have created. See, this is a game where the sun has to collide with the hydrogen atoms and escape from the other atoms. We're using the right arrow key and left arrow key for movement. And now the up arrow is used for the jump option. And now when we do this, it comes as game over.
Wow, this world is full of amazing things.
Yes, and nuclear fusion is not like rocket science.
We have learned many things about nuclear reactions in the universe.
The nuclear reactions do not only exist on Earth but also in space. Yes, of course. Nuclear fusion on Earth and nuclear fusion in space. Let us see a recap on the solar fusion.
Yes.
Now, it is time to thank our friends and teachers who taught us the wonderful topic called nuclear fusion. Thank
Thank
you.
you.